wonder how your graphics card transforms code into breathtaking worlds like Cyberpunk 2077 or powers AI tools like ChatGPT? Spoiler, it's not magic, it's 28 billion transistors working in harmony. Today, we're cracking open a GPU to explore how it juggles 36 trillion calculations per second, why its 10,000 cores beat your CPU's 24, and how it's fueling everything from Bitcoin mining to AI revolutions. Stick around, we're diving deep into the engine of modern computing. Let's settle the age-old debate, GPU versus CPU. Think of a CPU like a fighter jet, fast, agile, and perfect for quick, complex tasks like running your OS or browsing the web. But a GPU? It's a massive cargo ship built to haul mountains of data all at once. How? While your CPU has 24 cores, a GPU packs 10,000 plus. But here's the catch. Those GPU cores are simpler, specialized for repetitive tasks. Imagine 10,000 workers painting a stadium versus 24 artists crafting a masterpiece. Both powerful, but built for entirely different jobs. Or you can think of a CPU as a skilled chef preparing a gourmet dish, carefully executing each step in order. Now, imagine a huge team of chefs, each handling a small part of the dish at the same time. Need proof? Rendering this 3D scene takes a CPU 10 minutes, a GPU 10 seconds. Boom. That's why GPUs dominate gaming, AI, and even weather forecasting. Let's crack this open. At the heart of every GPU is the die, a silicon slab with 28 billion transistors. This isn't just a chip, it's a megacity of compute power. Meet the workforce. CUDA Cores, your mathletes handling billions of additions and multiplications for lighting and textures. Tensor Cores, matrix magicians, crunching neural networks for AI upscaling in games like DLSS. Ray tracing cores, light benders, simulating photons to create reflections so real, you'll want to touch your screen. Ever wonder why GPUs have different models, like RTX 3080 versus 3090? It's all about binning. During manufacturing, tiny defects can disable cores. Flawless dies become 3090s. Ones with flaws get downgraded. Think of it like a silicon beauty contest. Only the perfect survive. GPUs are data-hungry beasts. To feed them, we've got GDDR6X memory, 24 gigabytes of it in this card, shuttling 1.15 terabytes per second. That's like downloading 3 Netflix 4K movies every second. Your CPU's RAM, a measly 64 gigabytes per second. GPUs need this speed because rendering a single frame in Cyberpunk requires terabytes of texture, lighting, and geometry data. Miss a beat? Say hello to lag. To put that into perspective, running a game like Cyberpunk 2077, your graphics card performs 36 trillion calculations per second. To put that into perspective, if every person on 4,400 Earths did 1 calculation per second, it would take all of them working together to match a modern GPU's speed. Speaking of speed, HBM3E stacks of memory cubes deliver 192 gigabytes at warp speed for AI supercomputers. But unless you're Elon Musk, stick with GDDR6X. So, how do games use this power? Let's break down a frame. Vertex shading. 14,000 hat vertices transformed to 3D space. 25 million calculations. Ray tracing. Simulate light rays. Thanks, dedicated cores. AI upscaling. Tensor Cores sharpen pixels on the fly. Bitcoin mining. GPUs once ruled by brute forcing 95 million hashes per second. Now, ASICs do 250 trillion, making GPUs look like toy trucks. And AI, Tensor Cores multiply matrices to train models like ChatGPT. Without GPUs, AI would still be science fiction. So next time you game, mine, or ask ChatGPT for pizza recipes, remember, it's all thanks to this engineering marvel. If you enjoyed this video, smash that like button and tell us in the comments. Subscribe. Should we explore CPU architecture next or dive into quantum computing?